Hey there, welcome to today's video where we're going to finally be just making connections between all the stuff we've been doing so far in the unit. Again, we're just making connections basically between the tables of values we looked at, the equations that we've been given, the graphs that we've been drawing, and now when we see verbal descriptions, we're going to be talking a little bit about just some scenarios and matching up the scenario to the table, equation, and graph. Okay? Now, of course, we know that math is all about relationships, and we've been working a lot to identify independent and dependent factors and see the relationship between those factors, and we've been graphing things on the coordinate plane. A couple of examples of some relationships that we've already been working with so far. The relationship between a person's height and weight. As somebody gets a little bit taller, just think about as you're growing up and you're getting taller and taller and taller and growing, that your weight also tends to increase. Okay, that's what this says right here. When a person's height increases, their weight also increases. The taller you are, the more you're going to weigh. We also see it with the more hours that you work, the more hours that someone works, the more money that they're going to be earning. So again, in math, we've just been looking at the relationship. We've been graphing things on the coordinate plane. The things that we've been looking at, the main ways that we've been representing the relationships in math are, again, those tables of values, the table. We've been writing our linear equations like y equals mx plus b, and we've been graphing on the coordinate plane. So we're going to kind of dive on in here just with a scenario, and we're going to kind of look at the table, how we started out earlier in the unit. We're going to make sense of the equation that we now know how to write, and we're going to make sense of it over here on the graph, and we're going to make the connections now between all three things. So for this example that we have, a pizza company sells a small pizza for $5, and then each topping is an additional $2. So if you don't get any toppings, you still have to pay $5 for the pizza. That's $5 for the small pizza. Now, if you get a topping, that's going to be $2 extra. Okay. If you got two toppings would be $4 extra. So 4 plus the 5 is going to be 9. We can see that one more topping should be $2 more, and it is, and another topping should be $2 more. For the equation, what we're saying, y'all, is we're saying that it is $2 per topping, and no matter what, it's going to be $5 for the pizza. And you'll notice now, when we look at the $5, that's the cost of the baseline pizza, so $5, and that right here is on the graph. That's the cheapest that the pizza will be. This is now kind of coming back to it called a constant, because no matter what, we would constantly have to start with $5, and from there we're going to move up $2 per one topping. So you can see on the graph that starting out at $5, we're moving up $2 per topping, up $2 more for another topping, and then we'd go up $2 more for yet another topping. So down here on this axis, we've got toppings, and the cost over here is going to depend on how many toppings you got. So our independent factor here is the topping. That's represented on the x-axis, and the dependent variable here is y. That represents the cost, and we can see here on the y-axis that the cost depends on the number of toppings. So that's our goal for today's video, you guys, is to basically finally now draw the connections all the way full circle between the table, the equation, and the graph, okay? All right, so let's flip over now. And our goal is between a table, equation, and a graph, and now potentially a scenario to see out of these four things which one does not belong. So this graph might go with this equation. This graph might go with the table. This graph might go with the scenario. We're not really sure. We got to see which of these three connect with each other, and then one of them is going to be the oddball. Now we have a graph here, and a lot of people are visual learners, so let's go ahead and just kind of talk about some things we notice here with the graph. I know it's a little bit blurry and kind of small in your packets, but this blue point right here, the y-intercept, that's a 175. The scale here goes by 25, so 25, 50, 75, 100, and so on. So this is at a 175. So we can see right here, this ordered pair is going to be 0, 175. Now over here, this ordered pair in purple, this is from the origin. We're going over 7, and then we don't move up or down. So this is over 7, and then we don't move up or down. So we have here a graph, and now let's just look at the table of values. Do you guys see already that it doesn't match up? Because we're expecting a 0, 175, so that should be a 0 and then a 175. So this does not match up with this. Same thing here for the purple point. Notice that this ordered pair should be 7, 0, and this says 0, 7. So we can see that these two are not matching with each other, okay? So now let's kind of start to look at this equation. Now with the equation, I know that right now it's not in y equals mx plus b form. We always can rewrite it. We can rewrite the negative 25 with the x, and that can come first. And then we have a constant here, the plus 175. So what we want to do now, y'all, is we're going to focus. I'll highlight it. Let's just focus on this one instead, because now it's in slope-intercept form for us to be able to identify where it should start, which is going to be up here at plus 175. So let's see right here. Yep, we can see that this is starting to match here. This does match this. Now let's look at the scale. Do you see that it says we're going to come down 25, and when there's no fraction, we just put it over 1. So if we look at the scale, you see how it's going down 25 and then over 1, down another 25, then over 1, down 25 and over 1, down 25, and so on. So it looks like this graph does match up with this equation, and this table of values is an oddball. It doesn't belong with these other things. Now let's read through the scenario together and make sure that this scenario does in fact get represented with this equation and that it is shown here on this graph. So Tom works at an aquarium shop on Saturdays. One Saturday when Tom gets to work, he's asked to drain a 175-gallon reef tank. So drain means we're going to let the water out. He measures the amount of water that is draining out and finds that it is going to drain 12.5 gallons in 30 minutes. So it comes down 12.5 gallons in 30 minutes. And all I'm doing here off to the side is setting up a proportion to show you guys that if it's 30 minutes, we can double that to see how much it drains in an hour. So if it drained 12.5 gallons in 30 minutes, that must be 25 gallons per 1 hour. And if we look, it says it starts at 175. So it's when Tom gets to work, it starts up here. Then it's going to drain 25 gallons per hour, drain 25 for another hour, and so on. And when we get all the way to this point, what this is indicating, y'all, is that the tank is finally empty. And it took 7 hours for the tank to drain all the way. So yes, that's what this equation right here is showing. It shows it starts out at 175 and it loses 25 gallons per hour. So this does in fact match up. And what that means now is we can conclude that this right here, this table of values, is the one that does not belong with the other three. So we just made a connection between this scenario, this equation, and this graph, and we are done now with sample set 1. All right, so now here for sample set 2, which does not belong. So let's again start here with the graph. A lot of us like to start with the graph, and we can see that it's going to cross at a +2. Now, if it crosses at +2, that already lets me know something fishy is going on here. I don't think that this equation is going to match up with this graph. But what we don't know is which one is the oddball yet. We just know that they don't match. We can get the slope here. If I find another point on the line, it's right here. So I'm going to go up 2 over 3. So my slope of this line is a 2/3. Which does match with this, but again, it should cross at a +2, so this should say +2. So we're trying to find something that shows it crosses at +2, and this is its slope. Now, if we look over here in the table of values, let's look for these points on this line, okay? Let me move this back a little bit. Here we go. All right, so the first point, I'm going to move back 3 and then not up or down. So back 3 is on the line. 0, 2 is right there on the line. And if I go over 3 up 4, I'm on the line. So this matches this. We even see the y-intercept right here. There's the y-intercept. And it's at the 0, 2, so it matches. Let's look at the change in y's. over the change in x's, remember here on the y-axis it went up 2. So look at here on the y's, it's going up by 2, up by 2. So that did go up by 2. And then on the x-axis, after we went up 2, we went over 3. So on the x-axis, do you see here that these are going up by 3? So yes, we have verified that the slope is a 2/3 in this table. The y-intercept is the same. So these things are definitely matching up. And it looks like this equation right here is going to be the oddball. Okay, the equation this time does not match up. Now let's look over here and make sure we're okay with this word here, the wording, and that it does in fact match up with these top two things. So you guys know that the word quotient means it's the answer to a division problem. So the quotient we have of 2 and 3, and the input, plus 2, equals the output. And this right here, this equation, is modeled right here. There's the 2/3, the plus 2. So this line matches this scenario and this table. And the equation over here in this sample set, that's the oddball. So that's the one that doesn't belong. All right, and now we're down here on sample set 3. So when we start at the graph, 1, 2, 3, we can see here it's going to cross at a plus 3. And since I don't see any points up this way, let's move this way and see some points over here. Okay, and there's one right there. So we see that it crosses at a plus 3. So we know for the equation we should be seeing a plus 3. And this one is actually down 1, 2, 3, and then back 1. 1, 2, 3, and then back 1. Another way to look at it is to just go up 3 over 1, up 3 over 1. So the slope here is a 3 with x, and that should be the equation of this graph. We can already see that it doesn't match up down here, so these do not belong together. Let's come over now to the table. Now in the table, I instantly see this 0, 1. And I know that 0, 1 should be the y-intercept of this equation. So I think already now we can see that these might match up. Let's go through a couple of the points. Let's take the -2 and plug it in. If I do half of -2, half of -2 is -1. And now if I add 1 to that, I'm at 0. So yes, we can see that this does match up with this equation. We've got 2 points here to validate that. All right, so now if these match up, let's see which one of these goes with it. We already know this is an oddball. We're already kind of thinking this is the one that doesn't belong because this is the equation. All right, for the wording here, we have the output. So the output is half the input plus 1. So if we do half the input plus 1, it tells us that the output is half the input plus 1. So this equation right here matches with this and is the right one for this. So these three go together, and that means the oddball that we want to pick for which one doesn't belong is this one. So again, the goal of today's video was to try to look through, and given 4 different things, can you make connections between the 3 that go together? All right, that does conclude today's video. Thank you for watching.